Hello, and welcome to another 4-Minute Wrap-Up. I am Arindam, a PhD student at the Department of Computer Science at IIT Delhi. Today, I'll be talking about Frog, a fast, random projection-based one-class classifier. First, some background. What is classification? It is a task where the algorithm learns to distinguish one object from another based on the features of the object. Most common kind of classification one would encounter is binary classification. That is, when training data has two kinds of labels, for example, cats and dogs. The algorithm learns a decision boundary to separate the classes. But what happens if we do not have any examples of dogs in our dataset? Then we will have to deal with only one type of label, and our task now is one-class classification. The goal is to create a bounding region around cats. This problem is common in many real-world applications. To detect credit card fraud, for example, we have a lot of data about normal transactions, but it is hard to get examples of fraudulent transactions. There are many existing algorithms for this task that uses SVMs, decision trees, and neural networks. So why are we proposing a new method? Well, the real-world application we discussed deal with large data sets and often have millions of features. And the problem with existing methods is that they do not scale well. Now let's see the key idea behind a random projection-based one-class classifier using an example. Given a set of data points from normal class, for example, cats, we choose m random vectors. In this example, they are W1 and W2. We call these vectors classification directions. Then we project all our training points onto these classification directions. Taking the extreme projected points in each direction, A, D, and E, F, we get a bounding region around our dataset. Let us see how this fares against some new test points. A new previously unseen cat, Y3, is now correctly classified as cat. A dog, Y2, is also correctly classified as not cat. But Y3, may be a tiger, is now being incorrectly classified as cat. This is a problem of multiple modes in dataset. Our cat data points are clustered into two regions, but the region in between does not represent cats. This is a common problem faced by many extant one-class classifiers. Our solution is to simply split the box whenever projected points are separated by some distance greater than epsilon, where epsilon is a parameter we can tweak. Now the tiger is correctly classified as not cat. Now let's take a look at some salient features of Frog. Frog is extremely fast to train and test. A discretized and parallelized implementation of the above steps makes that possible. Frog also provides good theoretical guarantees for generalization. That is, given enough examples, if Frog does well with the training data, it will do well in the real world. More detailed information on implementation and theoretical analysis can be found in the paper referenced at the end. So how well does Frog compare against state-of-the-art methods? Well, it beats them on 8 out of 9 datasets. Also, it is up to 10 times faster than the best deep learning method. For more information on datasets and models used for comparison, please refer to the paper. Thank you for watching this 4-minute wrap-up. If you like this, please check out other 4-minute wrap-ups in our department channel.